Hello everyone, thank you for joining us today. This project, iJam with Channel Randomization, is conducted by the University of Hawaii and the University of Arizona jointly, led by Professor Zheng and Professor Ming. My name is Samson Aggelopoulos, and I would like to briefly go over the objective of this project. This work demonstrates an improved approach to reinforce physical layer key generation schemes. The original iJam applies friendly jamming to secure key establishment protocols against a single antenna eavesdropper. However, our analysis shows that such method would be vulnerable to attacks from a multi-antenna eavesdropper. Our enhanced iJam protocol employs channel randomization on top of the friendly jamming method, such that the clear bits are transmitted within a fast-fading channel. We further develop a angle of departure based channel estimation algorithm to cancel the changing effects for the intended receiver. The combined result is a communication channel stable in the eyes of the intended receiver, but randomly changing from the viewpoint of the eavesdropper. This physical layer technique would allow us to achieve secure establishments between wireless devices. Now I would like to go over the hardware we have set up in our lab. This device here is a transmitter, which we call Alice. Alice will be transmitting key bits at 2.6 gigahertz, connected to two USRPs. The antenna on the left is a receiver, which we call Bob, and the multi-antenna on the right is an eavesdropper, which we call Eve.
Hi, my name is Alvin, and I'll be going over the software we're developing to perform the experiment as well as to analyze the results. The software we're using here is LabVIEW, and we have the hardware connected to these modules in LabVIEW to control the signal being generated and sent, as well as to capture the received signals for analysis. So this tab right here is for Alice, and we can view Alice's parameters as well as the signal being sent by Alice. For this demonstration, we'll be transmitting on 2.6 gigahertz along with these other parameters shown. Alice has two USRPs and two antennas, as the rotating antenna will be used for transmitting the key bit signal, and the static antenna will be used to transmit the jamming signal to perform the iJam technique. Here, in Bob's tab, we can similarly see the parameters of Bob as well as set them, and we can see the data received by Bob. So Bob has just one USRP and one antenna in order to receive the signal transmitted by Alice. In Eve's tab, Eve has the same parameters as well, and the setup for Eve is that Eve only has one USRP and two antennas in order to attempt to recover data from the Alice by exploiting the spatial diversity from the signals received by the two antennas. In this last tab, we have an analysis of the data being collected as well as control over how the experiment is to be run. We can observe the bit error rate of Bob and Eve's received signals as well as the current antenna pattern of Alice as Alice's antenna rotates. I will now hand it off to Thomas to give a demonstration of our implementation.
Hi, I'm Thomas Yang, and I'll be giving a demonstration on our experimental setup. In order to begin our experiment, we need to first input how long our antenna will rotate. For our case, let's put 40 seconds. After choosing our options, we can hit start. You can see that the BER for Bob stays relatively low. However, we can also see that Eve's BER also stays relatively low. This is because of the multi-antenna setup that Eve has, which allows it to decode the received signal. Halfway in, we can flip this button to randomize our signal by having Alice pre-code the channel effect from itself to Bob. We can see that Bob's BER stays the same, since it can still decode the signal. Taking a look at Eve's BER, we can see that it has jumped to 50%, since it cannot calculate the channel effect between Alice and itself, so we can conclusively say that our method works. This concludes our demonstration of iJam with channel randomization. Thank you for your time.